Good morning, my students, year 8. We now study the sound. From the characteristics of the sound, loudness and pitch. Loudness and pitch. Loudness means sharp sound. Sharp sound. Sharp sound characterized by high frequency. High frequency. High frequency, high pitch means high pitch. Pitch, sharp sound, has high frequency. Loud sound has large amplitude. Large amplitude. Amplitude, the meaning of loudness. Frequency, the meaning of pitch. Loud sound has large amplitude or high energy. High energy. Sound may be loud sound or quiet sound. Quiet sound has a small amplitude or low energy. Quiet sound has low energy, has a small amplitude. This is the sound. This amplitude. This is sound, this amplitude. A small amplitude, low energy. Low amplitude. High, large amplitude, high energy or large energy. But the difference between loudness and pitch characterized by the frequency. Frequency indicates the pitch. Pitch, high frequency or low frequency. Sharp sound has high frequency. Sharp sound has high frequency, means high pitch. Loud sound has large amplitude, high energy. But quiet sound has small amplitude or low energy. This is the meaning of loudness and pitch. Sound may be heard or not heard, because sound, we hear it from 20 hertz to 20,000 hertz. Below 20 hertz, we not hear any sound. The range of audible frequencies is from 20 to 20,000 hertz. Above this range, human hearing 20 kilohertz or 20,000 are called ultrasonic. Ultrasonic. Ultrasonic, we cannot hear ultrasonic. Ships use echo sounder to measure the depth of water by using ultrasonic when it emits source of ultrasonic. These waves reach to the base and reflect. By measuring the time and distance, velocity equal distance divided time. A distance go and out reflected. This means that distance doubled. By measuring velocity, time is a time, velocity time is a time divided 2 equal d to measure the depth of water, sending pulses ultrasonic into mother's body and picking them after reflection from the baby can be used scan image for this baby. We can form image for this baby. This is an experiment to determine the speed of sound, in air. If we have two students are standing, this is the first A, the second B, are standing at a known distance away from each other. The distance between two students are known distance, like 250 meter, the distance between them, 250 meter. Student A holding pistol and student B holding stopwatch. Stopwatch set to 0. Student A fires the pistol. Smoke is seen by student B. So he starts the stopwatch. When student P hears the sound of the pistol, he stops the stopwatch and records the time taken from the sound to travel to this distance. Speed of sound can be calculated by using formula speed equal distance over time. Speed equal distance over time. Speed not velocity. Speed is a scalar quantity while velocity is vector quantity. Speed measured by meter per second. This is the unit for measuring of it. We can use ultrasonic in different ways. Reflection of sound waves is called echo. What's meant by echo? Echo is the repetition of sound due to its reflection. There are necessary conditions to produce echo. Number one, the distance between the wall, this is the wall, and the source of sound at least 17 meters. The distance at least equal 17 meters. And the time taken between the source and its echo at least 0.1 second to hear echo. If the time is less than 0.1, we cannot distinguish the difference between the source and the echo. When sound wave hits large building like this, large building or wall, sound reflects back, obeying law of reflection. What is the law of reflection? Angle of incidence equal angle of reflection. Soft material like sponge are bad reflectors. Bad reflectors because it has different angles, irregular shape. Sound reflected by different angles, not by equal angles, according to laws of reflection. The formula used in this case to determine the speed equal 2 times distance over time taken, because the sound move, go and back, reflect. The sound speed of sound in air, nearly equal 330 meters per second. Why this is the value? Nearly, because the speed depends on the temperature of the medium and has range from 320 meters per second up to 360 meters per second. This is the average. This is the average in this time. Example, to measure the distance, the speed of sound. If an experiment to measure the speed of sound in steel, we need to determine the speed of sound in steel pipe of length 200 meters is struck at one end with hammer. One end, this is the first end. Hammer in this. What happens at the other end? The pipe is connected to an accurate timer. Accurate timer in this end. At one of them, hammer. At the second, accurate timer. Timer record delay of 0.544 seconds. This is the time between arrival of the sound transmitted by the steel pipe and the sound transmitted by air. There is two difference. The speed of sound inside the tube, inside the tube there is air. The speed of sound in air not equal the speed of sound in the steel. The speed of sound in air 343 meters per second, not 330 as below. Calculate the speed of sound in steel. Speed of sound in steel. At first, any time equal distance over velocity or speed. Time equal distance, length of the tube 200 meter, divided the speed for 343. The time in air equals 0.583 seconds. The time interval between two sounds equals 0.544. This time in air 0.583 minus 0.44, the time through steel equals 0.039 seconds. This is the time through steel. Why we calculate the time through steel? Because we need to determine the speed of sound through steel. Speed of sound equal distance divided a time through steel. The speed of sound in steel equal distance over time. Distance length equal length of the tube 200. A time equals 0.039. The result equal 5,128.82 meter per second. From this we can observe that the speed of sound in solids 5,000. The speed in solids greater than in solids greater than the speed in liquids, greater than the speed in gases. The speed in solids 5,000 meter per second. In liquids 1,400 meter per second. In gases equal 340 or 360 meter per second. This means that the speed of sound in solids is greater than the speed of sound in liquid, greater than the speed of sound in gas state, due to the difference between molecules. In solids, the molecules close to each other. In liquid state, the distance more far away. In gas state, the wide spaces between molecules of gas. So that sound is flow or travels through gas with lower velocity than liquid, and through liquid lower than the solid. Okay? Goodbye and good luck, my student.